welcome everyone to the Wilson Science and Technology Forum. Our guest today is a new colleague of mine from Purdue University, Professor Ramses Martinez. Ramses is a member of the faculty in the Industrial Engineering Department and also has a joint appointment in biomaterials. Is it biomaterials, biomedicine?
Biomedical engineering.
Yeah, right. And Ramses, you probably are celebrating the news from U.S. News and World Report of the standing of Purdue engineering in the world and in the U.S. Just for reference, it is now ranked 5th in the country, just behind I guess it's Caltech, isn't it?
So the Department of Industrial Engineering for undergrads, so in terms of online ranking, we rank #1. In terms of education for undergrads, we rank #2. And for education for graduate students, we went up to #3, which is the highest we have been in the last, I would say, about 25 years.
Yes.
So,
well,
it is a big deal. These news were sequestrated, so we couldn't say a word. And now we're very happy to be able to share that with everyone. Yeah. So by the way, we occupied that spot after Michigan.
Yeah.
And we are setting it with the 3rd position with Northwestern, and if I remember right, it's Berkeley, the other one. Yes.
Well, I'm just really happy for the school. I mean, I spend time there. I know the faculty, and Ramses is a wonderful example of what I consider to be a very innovative and inventive faculty. And today you're going to hear some of that in his presentation when he talks about manufacturing of self-powered wearables for a healthier future. So Ramses, I'm delighted to welcome you here today. I think you're going to be your talk and your orientation will be a wonderful illustration of the connection between engineering and technology and society. And you'll speak about the work you're doing that helps people, which is, I think, exactly what we should be doing. So I'm very, very happy to have you with us today. And Ramses, I'll turn the floor over to you. Welcome.
Thank you. Thank you so much. It's a great pleasure for me to participate here. I was listening through all your presentations with all the different backgrounds that you got, and I'm gonna be using this presentation to kind of make myself more entertaining. There are technical details. If you have any, I will be very happy to address it. But otherwise, I will be flying through that and focusing on the real world problems that my research team is actually trying to solve. A couple of comments on my background. I have a funny trajectory. So my background is in physics. I went through the branch of applied physics, and material science was the thing that actually clicked with me the most. I went to the material science department at MIT during my thesis. Then I did part with Spain. Then my postdoc was at Harvard with Professor George Whitesides. That was when I was exposed to a lot of chemistry, and in particular, how surface chemistry changes the properties of materials was another thing that really got me really interested on how to harvest that and how to explore it for the good of people. And then I started my lab at Purdue. So I have a joint appointment that might look a little funny because it's biomedical with industrial engineering. So in the part of industrial engineering, I actually work in scalable manufacturing. So everything for me has to be, or any solution from my team has to be on how you can make something that is not like one of these nice demonstrations that you do on a clean room, that you only make one little device, and making another one will be just very costly. I need to make everything as low cost possible using manufacturing techniques that can be actually reproduced at a large scale. So the idea again is lowering cost, and again my joint appointment with biomedical engineering is because I'm in the area of instrumentation. So you're gonna see all these sort of wearables, smart textiles, and things that like that are low cost, have a nice conformability against the user, and because of that they are easily wearable, and they help us to get a lot of information from the user in order to achieve a personalized medical care. Okay. Other couple of things, I play chess. I have served as a voice actor in Spanish, of course. And so there are, and this happened in the US, so there are a couple of elevators and a GPS system. Nobody uses GPS systems any longer. And yes, and then there is, if you Google which one is the learning method to learn Spanish, like the first one you will get is the one that is called Rosetta Stone. Well, now maybe the Duolingo is actually taking over, but on the third one, it's called the Pimsleur method. Like that's the, like I'm the male voice for that one. So funny things though. Okay, so as my hobbies, since I was a kid, I was breaking toys and fixing them, and then like hacking on other things and making things to have an expand functionality. And you will see a lot of that as I go through the presentation. So I'm just simply gonna go through the problem very quickly, because everybody is aware that the way well, we live in a population that is aging very rapidly, and that the way we are dealing with healthcare makes no sense whatsoever. The costs are spiking, and they're spiking in a way that is just going to be unsustainable. Whenever the US is not able to hide the problem that we have with debt any longer, inflation is just going to be, in my opinion, the only way for them to fix it. Because if everything goes up, the debt kind of goes down, and inflation is just going to take many people without enough resources to pay for the healthcare that they deserve. Notice that this is something that has happened in many countries that were not able to develop as fast as the US or other developing or other well-developed countries were able to do so. And I just want you to know, like, this was 2020, so it was like basically in this decade, again, it's over 5 million children died under 5 years for causes that were preventable and treatable. Okay, that is, in my opinion, something I feel like deep shame on, like, developing science, getting like all these advances in pharmaceuticals, and still not being able to take care of people that are like us. It's just, it doesn't tell much about our civilization, in my opinion. And again, we need to basically find solutions that ensure that we make people the same in terms of like access to at least minimum resources. So again, the idea for me was like, okay, so how do I figure out a nice system or a nice method to make diagnostics more affordable? And then immediately, like we thought, like, okay, so in order to make something scalable, like or to fabricate something in a scalable way, you need to use a substrate that exists on any country, okay, or a substrate, a substance, something that is produced on every country. And then, and it is produced at a low cost. Yes, because in a previous presentation, I asked like if anybody knew like what is produced in every country, and somebody said beer. And that person was right, but it's not at a low cost. So the answer is paper. Paper is produced in every place on of the world, and the problem with paper is that it soaks very easy. So I'm gonna show you now a video, and on this video you can see how this is conventional paper. You have it on the left, and then the one that we treat at the lab with a hydrophobic coating is on the right. Notice that this hydrophobic coating that we do are actually molecules that self-assemble on the surface of these, on the cellulose fibers of the paper, and they are not affecting the breathability of the paper. So we can do this with paper, we can do this with textiles, we can do it with multiple fibrous substrates. That is going to be becoming quite useful, you will see. Okay, I also want you to notice that even though what you're gonna see, these two videos were recorded with a high-speed camera, and they happen simultaneously. So in the top view, you see this is a drop of blood, and you see how it rolls. As it rolls, it actually doesn't show any receding contact angle. So basically it rolls very spherical as it rolls down. That means that there is definitely minimal adhesion, and you can tell that in the moment that it touches the table, basically the adhesion with the substrate is very obvious, and then it stacks over there. This is going to be quite useful for us to deal with samples that come from the human body, as those samples are not only made of water, they are actually complex solutions involving fats and salts, and sometimes they have funny pH, something. So this approach of treating the surface of well-known materials allows us to lower the manufacturing cost, for example, of Petri dish. So what you have over here is basically a Petri dish that was manufactured via origami. And again, the cool thing about this is like Petri dish allows you to like these well plates or Petri dish allow you to do multiple samples. And do multiple testings out of the same material, out of the same sample, sorry. And however these samples come from a human, they are going to be contaminated, and it makes no sense to actually recycle these Petri dishes. Like you have to burn them to prevent any cross-contamination. So if you can burn paper, why not using paper for starters, as basically produce a minimal byproduct that is biodegradable. So that's why we changed into this technology, and again created a solution that is way more sustainable. Very good. What you're gonna see over here is a video that shows that you can actually run microfluidics and use very small samples in terms of volume to create diagnostic tests out of a single drop of blood. Okay. Very cool. And again, you can even see in this image how we can get like serial dilution. So with a sample and some solvent, you can actually create like multiple subsamples for different testings that you might perform later. So my group then was very interested about this technology, but just notice that if you do any sort of microfluidics out of paper, you're gonna need to do this in a lab. And labs require to have a syringe pump, require some tubing, things that are expensive and things that cannot be reproduced easily in another place that is not a lab. So we were thinking like, okay, so is it possible that we can take these systems out of the lab so that they can serve or be useful at the point of care? So what you're looking now is basically a paper-based device that has 4 regions on the corners. Each of these guys allow you to create electrochemicals or to perform electrochemical sensing. This electrochemical sensing is actually quite useful to detect analytes in blood. You just simply need to prick your finger, get a single drop of blood, and the paper will basically take it in, and because it's hydrophobic, it will center it only in the testing zone right at the center of the device. Then the electrochemical testing can run, and you can read it in the miniature device that you see clipping the device. This will allow you to monitor glucose and monitor other metabolites related to the kidney, to the kidneys and the liver, which might help particularly at the point of care in low resource settings. How is this power? Well, it is actually very cool, because you might be thinking that that piece of electronics over there contains a battery, but it does not. It actually contains a capacitor that you can charge by tapping on the back of this paper-based device, as basically what it does is it actually steals the charges from the fingertips of your hand and stores those in the capacitors. So using low power electronics, you can run the electrochemical test later on. Okay, so this idea of having a completely power-free approach of performing electrochemical tests was quite new, and again allowing us to take our technology one step further to the point of care and to the point of need. So I'm going to show you now another one. This approach was like, okay, so My son is 5. He absolutely loves transfer decals. And he like sometimes like when there is a birthday party, he wears them like all over the place and even the face. I'm just trying to get him like not to put them on the face, but we're still working on that. So now the thing is, those transfer decal exhibit a very nice conformability against the skin. So can we make those cheaper and can we make those so that they serve a medical purpose? So, we thought like, okay, so let's actually do the same. Let's put our piece of paper on top of a hot plate and let's render it hydrophobic so that only the top surface of the paper remains hydrophobic, but not the bottom. That allows us to spray conductive particles on the other side of the paper. And if we take this to the laser cutter, we can trim these serpentine designs, which are very conformable and actually stretch as our skin does. So this allows us with this water-soluble tape to put them on the skin of the user and actually get like very nice conformation. And you will see in a video in a moment like how my student was able to just move the wrist, and the electronics were actually attaching like quite nicely. You can put LEDs on the electronics and do wireless power transfer. You can actually, because they are completely hydrophobic, you can wash your hands and they will still work, and they actually work even when immersed in water or immersed in oil. So so this is my student. Again, I just wanted to give you a hint of like how this looks like. And this epidermal paper-based electronics, they just simply work with that tape that you see over there. It's made out of a polymer that dissolves in water quite easily, called PVA. So you just simply need to squirt a little bit of water, and you will see in a moment how that back substrate disappears, and as soon as it does, the electronics will be completely adhere facing the user, and the user will be able, to simply like scrap them off at the end of the day, and they stick very nicely, and then they last until like the user decides to remove them by peeling them out. Okay, so this technology is not only compatible with the skin, actually it is implantable, and that's what you see on this little mouse. So after getting it anesthetized, we just implanted this under the skin. The device looks okay. Now you might have the question, and it will be very reasonable. Why would you put an LED inside a mouse? Okay, so the answer is that there is a discipline called optogenetics, where what they do is they introduce photosensitive chemicals inside the brain of a mouse, and then depending on the light stimulation of these chemicals, they can actually change the behavior of the mouse and study many different things at the like behavioral level, psychological issues, and basically how the brain works and the speed in which signals are transmitted. So at the bottom, though, what you're seeing is a different mouse, and this mouse is actually having a sarcoma. So sarcomas are cancers on the fat cells, and those are horrible. Like they spread really like a wildfire. So they proliferate a lot. They have plenty of space because, under the skin, you have a lot of flexibility. The skin actually stretches at 30%. So, so that means like, it basically gives a lot of space for the cells to keep on proliferating. Now, how do you kill cancer cells before you kill the user? There are many radiation ways, about like chemotherapy, but one easy way is actually to put something that you can heat up using wireless power transfer. And then when you heat up the area where you have the cancer or the tumor, what happens is that these cancerous cells, they are actually all wired up. They are really pumped up in their metabolic activity, and they need a lot of oxygen. So when you heat up the area, notice, by the way, that I'm heating the area over here. This is around 42 Celsius degrees, so it's not enough to cook the mouse or the tissue. but it does require the cells to burn a lot of oxygen. And if there is no oxygen around, because they deplete it fast, what happens is that they suffocate and they die. And they die while the healthy cells that don't consume that much oxygen remain alive. So using these heat treatments or localized heat treatments, it is actually terrific to be able to do that and be able to reduce the size of the tumor. Notice over here that because this is made out of biodegradable materials, there is no need for you to remove or to have to perform another surgical operation to remove it. You can just leave it there, and the body of the mouse will just simply bioresorb it with time after the therapy is completed. Okay, so you have over here other stickers, and you also see how we can put them on the sides of the, like on both sides of the eyes. And this allows basically for pilots to know like where they are looking just by monitoring the muscles, just monitoring in which direction they're looking at. You can monitor your activity in muscles, which makes them very inexpensive sensors to perform fatigue testing. And you can even get them, again, near places where you have an artery in order to record the signal that the signal from the heart and see how the heart is performing over time. Also, I want you to keep in mind, again, this is made out of paper, so you just get any fire close to them and they disappear into gases, minimizing any byproduct or residue, and therefore making the solution not only compatible with single use, but also very sustainable, which was what it was desirable. And again, notice by comparing with the conventional electrodes, because these stickers are very close to the skin, they exhibit minimal noise due to mechanical motion or mechanical sliding on the sensor over the skin. So they perform very well, and that's and again they are cheaper and a more economical way of or sustainable way of performing this test. So now with this technology, what else could we change? Bandages. Bandages sounded to me always like they were a little like too simple, and we wanted to see if we could hack into them. And what we did was just making our substrate, again, hydrophobic. We made our sensors, okay? And we just simply put them in a way that they are folded so we can interface through the bandage, through the sticky part of the bandage, and we can put or place the absorbent pad right on top. Notice these are conventional bandages, and these are actually, I wanted this to be as inexpensive as possible. So these ones are the ones that come from the dollar store. Okay, so now you can see we have two of them, and the reason is that one is going to be, the model on the left is the one that actually checks on the proliferation of bacteria under over the wound, which is something that happens a lot, particularly for people with open wounds. The other one is actually able to detect pressure ulcers. This is for people who have been in bed for too long, and then the constant pressure in an area is actually causing them to develop these pressure ulcers. We made as adorable as possible the electronics, and notice again it works with a wireless 2.4 antenna. So this frequency is the one that your cell phone uses, so it sends information to cell phone, laptops, whatever is available. And we test them, they work really nice, and again they can provide information about bacteria proliferation and about any damage caused by constant pressure in the area. So for monitoring patients, working quite nice. And easy adoption, as they don't weigh very much, and they're completely wireless, and you can throw away the bandage while still keeping the smiley face with the electronics and transfer that to another one.
Ramses, just a question. What is the lifetime of a device like this, a bandage? How long will it continue to be functional?
The bandages are supposed to be changed 4 times per day. However, people change them maybe once per day. Whenever they get wet, people change them. So now the device is supposed to, the device is basically, okay, the device that you have over there is basically, it requires expensive chip. However, those chips were too expensive for us to use. So we ended up hacking one of these. Let me see if I have one. In my room, I'm trying to point at that with the camera, but I have one of these smoke detectors. So we took smoke detectors because they are way cheaper. You can find them in the order of like $12. And basically took the chip and use it to serve as the electrochemical analyzer that we are using for these smart bandages. That is fairly inexpensive and it lasts as long as the battery does. But the battery can be easily exchanged with, is one of these like conventional flat batteries, like for, yeah, the ones for like Texas Instrument calculators, like the thick ones.
Oh, yeah. Got it. Okay. Thank you. Thank you.
All right, and again, the technology is also compatible with just like putting alcohol on top of it, so that you can easily clean it and ensure that there is no cross contamination with the next bandage that you want to put on top. Yeah. Okay, so what I want to show you, this is actually very new. It's coming from again from my lab very recently. The idea here was, okay, can we do the same with it for the smart bandages? And actually monitor diapers. Can we make smart diapers? And the diapers is something that, like, actually affect vulnerable population, people that are either like very young or very old, and they don't do well communicating when they need a change. And honestly, there are not very good solutions. I mean, I have been changing diapers very recently, and I can tell the only thing that you get as an indicator is something that changes colors. So can we have something that provides better information? And not only that, but also performs an electrochemical test on the urine, so you can actually tell if there is a urinary tract infection developing, or if there are some internal bioanalytes that basically are unbalanced and require the user to be to go to the doctor so that they can check what is going on. So we develop a new polymeric mixture that actually performs very nicely and can be stored over more than a year without any reduction in performance. And we use that in a printing method that again is scalable but a little tricky to detail like fully. And we were able to make these sensors that you see over here, which are bendable. They are protected with this hydrophobic coating so that the droplets cannot short circuit the electronics. And the cool thing that they have is that they actually end in a way. So by the way, we put this paper-based electronics embedded into the wetting part of the paper, so the part that actually accumulates all the fluid. So the fluid only reaches the areas where we want to perform like the test. And we are testing for dehydration, we are testing for urine volume, we are testing for the pH of the urine, and metabolic activity and glucose. And in this case, the sensing mechanism or the electro Okay, we actually call this wireless analyzer, contains all those electronics that we made as small and tiny as possible and pack it into this click-based mechanism that you just simply need to click on the diaper. And when the diaper is done or used, you just simply clip them in another one and basically allow to reduce the electronics, lowering significantly the cost of having smart diapers. So the idea here, again, you just dispose the diapers. These are single-use electronics, and they have a very high, shelf life, so they can last the store for a long time. Notice how we perform like numerical simulations in order to be able to calculate the volume of urine that was arriving, and also how they perform as nicely as this is a $30,000 benchtop pH meter. Okay, so it's a state-of-the-art, measurement systems for pH, and our like low-cost electronics just does the same in less space and actually weighing less than, I think it's 65 grams, the whole thing. So okay, and very cool thing, myself and my students had to wear this, and we changed our diet. And basically, we were able to monitor how changes in the diet actually affect the urine right away. And this is actually making this technology able to monitor patients over time, allowing to basically see how the changes in their diet are affecting like their metabolic activity, and basically moving one step forward towards like personalized medicine. Okay, so the last one, I don't know if it is, no, I think I still have a couple. So I wanted to show this one. This is on edible electronics. Now is, can we make something that can predict if food is actually going to be wasted, like if food is not edible any longer? Again, there are a lot of people like that die every day and every year because they eat something that they shouldn't have. So, and it is just like this unsafe food is difficult to tell, and people that are in need, they don't have the capability to know. So we made a substrate that is actually fibrous and contains multiple layers, and each of these multiple layers were actually tuned at the nanoscale so that they were able to swell or swollen, like to swell, whenever moisture inside the package was present. So how is this working? Okay, so their piezo and triboelectric response changes accordingly. So whenever you tap the surface of this sticker, actually the voltage that it generates depends on if there is biogenic gases that indicate that the food is unsafe or if there is not. Okay, you can actually have them right in contact with the food item that you want to monitor, and this one has a small tiny coil that actually sends a signal to a reader, and if the food is not good, and this one is just inside the package. And this our idea was like, okay, you can put these sensors in close proximity of the food. You have no problem whatsoever because you use all the materials that were used in the manufacturing of these sensors were edible, so there is no problem with toxicity, and the user can actually eat them. And according to my students, they taste like Doritos. So and just by tapping on them, they generate enough charges to detect if there is either TMA, cadaverine, or ammonia, which is basically how meat, fish, and fruits decompose. So those volatile agents are difficult to measure otherwise. And again, this technology allows to just do this in a way that allows us to even detect the difference when you leave meat inside the fridge or outside the fridge, like basically letting you know that, like when it reaches levels that are unsafe for consumption. And you can see on these like nice green images that these are cells from the intestine of humans, and basically they were able to proliferate on top of these devices, and basically this means that like the devices can actually be biodegrade by your when they reach the stomach, they are basically digested, and they don't cause any damage to any cells in the digestive tract. Okay, so I'm just gonna move now into wearables, and I'm just going to show you a couple of goodies here. So the idea was, okay, can we make a system that allows us to harvest the triboelectric charges generated by the contact between the user and the clothes and use those for something useful? Okay, so by performing some patterning and some embroidery on top of conventional textiles, we were able, and of course treating the surface so that the textile is actually able to perform well even underwater. The idea is that the multiple layers on this device actually are able to steal the charges from the tip of the user, and when you tap on top of them, you actually get to, for a brief period of time, to enjoy from a little bit of electricity generated. So now, where do we place them? Well, in places that exhibit a contact with a surface quite often. That means socks are good. The area under the sleeve is basically when we walk, we wrap that area a lot. So like embroidering something over there is actually quite meaningful. Or wherever we have joints, because we move our arms a lot, and we are basically able to harvest all that mechanical motion into something that allows a capacitor to charge, and then allows that capacitor to discharge on the device that we want. So over here you can see how this performs quite nicely underwater, and how they can be cleaned right away. And I'm gonna show you. Is this a video? Yes. So So this video has music, and when my student can pause the song and play the song again, and turn the volume down, turn it up again. All right, and this is all coming just by harvesting these charges and by creating judiciously engineered electrodes underneath that make our wearables not only smart, but also compatible with the washing machine, which is something that was just not possible before. We also made other wearables that actually exploit a new mixture that we made that is actually able to make very conductive electrodes using biodegradable materials like silk and carbon nanotubes and carbon species that are actually derivatives from crustaceans, and then those are able. I just want to show you this one. There was a lot of interest from Duke Energy about this, because they have people that are working outside, and they don't know if there is some. I mean, they are trying to check if there is power on the line that they are touching. However, it is like if you don't have the tester and you don't care much about safety, you might think like, it's okay. I mean, it might not be alive. So that's why we created this glove that basically what happens is that it actually can detect voltages and live lines nearby, and it lights up on the fingertip whenever the power is on. Okay, when the power is off, it cannot detect anything, and therefore is not able to harvest that energy from the live wire to power the LED. So again, the idea is that using technologies that currently exist and is a scalable manufacturing process that are compatible with the textile manufacturing and things that have been done for a very long time, like making paper and doing embroidery. Like we can do a lot for a low price, making technology accessible to those that don't have the financial stability to focus on those things. And what we do, if we are able to take these solutions to the user, is we make these people not to need to go to the hospital in order to monitor their health. That means that they don't need to go and create like long lines at the hospital at the cost of like increasing the price of medical attention. Basically, they just need to go when they need it. We can send people home faster because they can do their post-operative checks at home. And maybe they might not need a doctor to go and check on them if they have an open wound. Maybe they just need a nurse, which is cheaper and makes a better use of our doctors too. So there are many things that we could be doing, and again, that's I feel very grateful to my mentors, to my collaborators, and definitely to everybody in my group, as it is a pleasure to work with them and to figure out what is the next thing that we can hack into in order to make sure we put our contribution towards a healthier living. So that's all for today. It was again a pleasure to participate in this forum.
Well,
Take any question you may have.
thank you so much, Ramses. You know, I'm just curious. Earlier this year, there was a problem with deli foods. Boar's Head had a major problem. How would your technology have been useful during that episode?
Yeah, so with food, it's always the same. It's somebody is sloppy and messes up with the best by dates, and basically like there is a mistake over there, or somebody thinks like, this is a little expired but not too much, and then like it's like, you know, like they will eat it, and then they just simply move on, and then they might cause a great trouble, because in some cases it's basically not people just like being reckless. Is sometimes like you trust the truck that is moving one food item from one place to another one, and maybe the cooling system didn't get to work, and the person driving couldn't care less, or like was not even paying attention. So maybe this cold line gets broken at some point, and basically, and this is something that can be clearly seen on this graph, the one on the right now. In the moment that you have like meat, particularly meats, outside the fridge, things start, like bacteria start to proliferate very fast, and it's just it's a very moist and protein-rich environment. Like bacteria loves that.
Right,
So
right.
the idea would be like, okay, so can you just simply have these systems or these stickers inside the package? It might be a cereal package. It might be like you know, any package where you can just simply stick them inside. I forgot to mention, but on we put like you can see it on the strawberry. We put a layer of microfibers that are actually self-adhesive. So you can just like simply put them against something slightly wet, and they will immediately fix and attach to that surface. So then whenever whoever is selling the item should, or whoever is like recharging the machine that is making the ice cream, or like whoever is like putting that in the cell in Walmart or whatever place, just can simply tap the system against the reader, and they will have a readout about like how, like you know, how okay is that food. That will also be able to tell like, okay, maybe like there are many food items that get that get discarded way too early, and that's a huge waste.
Yeah.
So why not donating that food? If you don't think like, if you don't want to sell that to like your customers because you want only the fresher stuff, I understand. But there are people, I mean, there is still like hungry people here. So so why not being able to facilitate something just by making sure it is safe in the first time, and then like just sharing with those that do not have the resources. Okay, we have a hand up. So
Yeah. Let me just ask one
please.
quick question before we go to Eddie. You know, I know some people who are affected by that boar's head contamination. The problem, as I understood it, was related to processing at boar's head. The products found their way into the deli service,
Mhm.
but the problems only became apparent when people ingested the food and became ill.
Yeah.
So is there a way that these kinds of detectors could be used by, for example, delicatessens or supermarkets or people who are storing the food before it ever gets to the public?
The mechanism over here is triboelectric. It takes charges or tapping. The other approach, the one on the strawberry that you see, is actually merely wireless power transfer. There is a small coil made out of an edible. It's actually magnesium. So it is edible. And then what I wanted to say is you can have a reader that just simply you just approach the food. Like I don't see any reason why, for example, when you go to like to a store, when they are actually weighing your bananas, why they cannot have on the scale the reader that is necessary to communicate with the stickers and immediately be able to report if the bananas are good or not.
I think that would be a real service to society. You know, if that could something like that could be done, it would spare a lot of people some very uncomfortable moments. But all right, thanks, Ramsey. Let's go on to Eddie.
Thank you.
Yeah, hi. It's very good talk. I'm afraid I came a little late, but my question really is perhaps more to do with monitoring. Many years ago, I tried to develop a stroke meter, you might say, to detect potential strokes before they kind of happen. Um, and I won't go into the details of it, but it struck me that two things. One is that if you could have a monitoring system on people, particularly elderly people who are prone potentially to stroke or heart attack, that you could monitor them and get help to them should an event happen. I mean, I have a pacemaker that continually talks to my iPhone, for example. The other thing is that the amount of power that you need for this device seems extremely small. And I wondered if it could just run off the pulse of someone, particularly if you attach it, say, near the carotid artery, where it would actually be receiving a reasonable pulse, at least for most people.
So yeah, definitely that is something that we are currently in need of, such technology, and meaning the technology of being able to monitor and actually what we need is to predict when the
Yes.
part is not going to be like working, when failure is coming up. And honestly, we do that very well with in industrial systems. There are prediction algorithms that tell you when you need to exchange something, when you need to take care of a machine, when you need to clean something, and that saves a lot of money. Now the problem is, like with a machine, the machine is not going anywhere. You put your sensor over there, you measure constantly, you get big data, and that's terrific. That's exactly what we need to do with the heart. Now, with these stickers, for example, like you can tell, or like even conventional electrodes, what you can tell is like they depend, like the signal depends a little bit with where you place them in terms of intensity. So a more wearable solution is definitely like way better. Okay, and this idea of actually not only making it wearable, but making it implantable. So it is implanted in the right spot, and we make sure it's not going to be moving because it's like nicely attached to that area and maybe takes the pulse from an artery, or like that will be actually the best way to go in order to take or to collect information about the heart over the long term, because it's only over the long term when we can actually do meaningful machine learning methods that can point at or predict when failure is coming.
It was one of the problems that I faced, was actually getting sufficient data and then determining when something was happening that was not that you should be reacting.
Your question had another dimension that makes the problem actually a little harder, and it's the fact that you said, like, because this is using little power, you can actually, like, it would be actually nice to have it implanted. But it is a little trickier than that, because measuring the heart requires power that is a little higher than tapping. Okay, so but you don't need to be monitoring the heart at all the time, like all the time. Like you can just monitor the heart every 5 minutes, and that will be already providing you a very large data set when you do that for years. So the idea is that multiple motions need to accumulate the power that they produce in some sort of a capacitive system. And those capacitive systems are the ones that are a little trickier to implant in the body without proper encapsulation. So, for example, my dad uses what is it called? Pacemaker. Yeah. So, in my opinion, rather than putting a battery over there, and definitely I can tell, like, if you miniaturize things properly, there is a space over there to put one of these capacitors and to actually be able to record at the same time. I see a lot of opportunities for those implantable systems to monitor heart activity in a way that like can be plotted in a cell phone and can be actually plotted over the over many long periods of time for your doctor to be able to make better decisions. And this more providing or to be able to guide doctor decisions will always come with better outcomes and lower times for the doctor to figure out what is going on. So thank you for the question.
Yeah, Ramses, before we continue, maybe you could stop the screen share so we have.
That sounds good to me. Yeah, this is more of a conversation. Okay, so I'll do.
And we'll go to Tom.
Yeah, I had two questions. One, at one point when you were talking about your Band-Aid, you actually did, to clarify, an analysis essentially of, sort of the quality of the wound. Like you were doing some analysis of some, was it an effluent that was you were seeing, a compound that was coming off?
No, so bacterial proliferation is something that whenever you have an open wound, like usually this is very common with people that are either overweight or going through diabetes, and some other people just happen to develop one of those just by bad luck. Also, smoking affects a lot. What happens is that bacteria loves that area. Again, it feels like fresh meat. It is actually receiving a lot of oxygen, so it is very easy to proliferate. Proteins all over the place, moisture. So a byproduct of bacterial proliferation is actually acidic components that alter the pH significantly. Okay. So by monitoring the pH of the wound exudate, we were able to figure out if there are many works on literature telling you which ones are pH values that are indicative of that. Yeah.
All right. So basically, you had built essentially a pH sensor that you could wear. That you were wearing. Okay.
Yeah, that was completely flat and engineered so that it was hydrophobic, so it will not be short-circuiting every time like you wash your hands or like wetting, but it's still hydrophilic on the side that was sucking or by capillarity taking the wound exudate necessary for the measurement. Yes.
Okay. And then the other question I have, I'm not sure what the sort of the right word is for these kind of sensors, but what is there's a term, technical readiness level. So what is the sort of what is the level at which, how close are you to actually deploying these essentially in sort of the general environment?
So everything you have seen has gone to the Purdue IP department. So everything is protected for patents and all these things because they see the value and this stuff. Now, several companies, and this includes like Apple now is actually having a branch that is, I think what they do is they have a company, they buy a company that does wearables and then just get them into that. So we talk to them, we talk to Meta also has something similar, and many other like biotech companies. So the point is, it is this, they tend not to be interested in single-use solutions because it's difficult for them to put a high price tag to the solution. So now if you make for pressure ulcers, for example, they were more interested in getting our technology not as a sticker but a sock, so they could actually charge something in the order of $60 for having a special sock that monitors that. And that's the main problem for us to be able to send this into production. The fact of a strategy that focus on a scalable production and lowering cost of something that actually brings something new. That's why even though this is the experiments are easy, the materials are low cost, so everything reproduces nicely, but the TRL is actually quite low because again, I don't find companies that are into they don't see the value of exploiting this approach.
Thank you.
Thank you.
Let's go to Michael.
Very interesting. I appreciate this technology. One of the major issues with the health of our population is that the food we're eating is dead. And the reason it's dead is because the soil's dead. And the reason the soil is dead is because we farmed the life out of it. And we're essentially just pouring fertilizers into the soil. And there's no real microbial life left in the soil. So as a result, you need to eat 5 apples today to get the nutrient value of 1 apple in 1950. Now, the whole issue is nutrient density of food. The higher the nutrient density, the better the food, the healthier the populace will be. The way you currently measure nutrient density in food is by determining the levels of the micronutrients in the food. It's very difficult to do this because in some cases, for instance, in boron, you're looking at parts per trillion in the soil, which translates to a level in the food that can't be measured. So the way we measure nutrient density is by measuring the sucrose level in the foods, because it is directly proportional. The higher the sucrose, the higher the micronutrients. The way we currently measure the sucrose level is we crush the vegetable or the fruit and get a juice, put it on a refractometer and measure the angle of refraction, which gives us a number, which is in terms of units called bricks. So high bricks food is high nutrient. So a 15 bricks tomato will virtually dry rather than rot on the shelf if you sit it there. So the whole issue is there a way to measure the nutrient density of food, either at the production level or at the consumer level? And it seems to me that your technology might be incredibly valuable in doing this, and the implications are enormous.
So I appreciate the comment a lot. Yes, making like nutritive food is actually very important, and we have actually like hunger is still a huge problem like even these days. So so like being able to address it in that way, like that will be very meaningful indeed. I have to I want to bring to the table one problem that I have with the technology you have seen is basically those are stickers. That means that they get information about the surface, okay? Or if there is something nearby, for example, like what we are doing is we use them as gas sensors. If the fruit is producing gas, okay, like bananas degrade and like they degrade the one nearby. So if that biogenic gases are present, we would be able to detect them. But what you require is actually test the inside, because the nutrients are mostly in the bulk of the food item. So that will be definitely way more challenging, and I don't see how this technology would be able to go into this direction. I have to say though that again the problem we were trying to solve was just simply different. It was only about like not to get people eat what they shouldn't. Okay, in terms of like food safety. And I might also have to say here that if we do the mental experiment of remembering or just checking on the person in front of us in the supermarket, what do they have? It tends to feel to me that like people buy more what tastes nice more than what is nutritious. So, or like what they should be eating. But that's I really appreciate the comment, and I actually never got to consider that dimensionality of the contact with food. So I appreciate it. Thank you.
Michael, you're muted.
Yeah, please unmute.
Michael, you're muted.
Perhaps the use of the juice itself might be some other means to put it onto your sensor.
Yes. Yeah. Yeah, that would be great, because in the case, if we can make it pass through a membrane, like, and the membrane being our sensor, definitely we would be able, or even with the vapor from the use, we would be able to tell. I can tell you already that many companies who sell juice will not be very interested in getting this technology on their packages because of the nature of what they sell. But but anyway.
Okay, thank you.
Thank you.
Let's go on to Albert. But Albert, I have to say, I mean, this is a discussion about medical care. You look like a patient today. What's going on?
I had food poisoning by strawberry this morning, and I'm
Oh,
recovering in bed. So
Oh my
your
goodness.
presentation is very apropos.
Oh,
I have
Very
two
good to hear.
questions.
yes.
One, on the strawberry, your sensor measured the gas coming out. And to measure gas, it seems to me measuring it at the container level will be easier than at the individual strawberry piece level, because then the gas will build up and stuff. Have you considered that? Of course, the container has to be sealed, and many products have a sealed container. So that's one question. The other one is what you described about the Band-Aid. Interesting technology for everything you said. However, you're measuring detection. What about just adding some stuff that fixes heals your problem? Like, I don't know whether it's probiotic or antibiotic rather, that you attach to the Band-Aid using your technology, which would be, in my mind, a lot more practical, quick results than knowing that you're getting sick or you're getting infected rather.
Very good. So yeah, so on the strawberry, the different fruits and different food stuff generates different amounts of biogenic gases. For example, if you take, you know that every time you buy your bananas, they actually have the tips coated, or they just put like some wrap on top of them. It's because that's actually, that cut over here is the first one that starts generating the biogenic gas that leads to the getting all of them to turn black really fast. So no matter where you put them, like it happens maybe a little, maybe in the fridge they last a little longer, but then they start tasting weird. So my point is, some substances produce very little amount of biogenic gases, and those substances require to be in a closed package, so that the accumulation of biogenic gas is what is detected by the food sensor. Notice that the size of the food sensor needs to be made in a way that matches the amount of gases available. Like meaning, like, depending, so every single food package, or every single food package, every single food will require to have a specific sensor so that the sensing can happen, because it needs to be calibrated for that particular food item, just so the calibration matches. In the case of fruits, and I would say this includes strawberries and bananas, the amount of biogenic gases that they produce is actually fairly large. So you can put them in only every 10 of them, as they do with the stickers, and just get enough information about like the whole stand, I would say. Because those gases actually like surround the surface of the fruit, and that they would be able to be catched by the sensor. Your second question was on the idea of not making passive smart bandages, but the smart bandages that are actually active, that take a role into solving solving the issue that you might be having. Like if you already detect that you have bacteria proliferating, why not doing something? So I agree with that. Usually the reason why that was not into consideration with the bandages that we use were because they were like the most inexpensive bandages, the ones that you are supposed to change. And also because we were focused okay. So if you're going to be exchanging them, you are better off by just taking them out whenever the sensor says like, hey, you have bacteria now, so it's time for you to clean them, because you were like putting your hands in dirty water and something proliferated before it should have. So you remove them, clean, put a new one, and move on. Now, if your question was more like what happens with people who withstand burn wounds, like you get burned on, let's say, 25% of your body, yes, you need a bandage, you need to cover that area, and you better not have the nurse checking, which is, by the way they do it, and it is really painful. They go check and they check if it smells funny, or if the color is changing, or like if it is generating too much exudate, that usually indicates that the body is sending all the water over there because an infection is appearing. So how would you, what would be the approach? Okay, in this case, when you're expecting the bandage because you are hospitalized, you require the bandage to be there for a little longer, also because just to minimize the amount of changes of bandages that you do to the person, because it's super painful. It will make sense to put a hydrogel that actually is loaded with healing factors. These healing factors are basically molecules that promote the proliferation of tissue. And the other thing that you can do is to couple those with a heating element. And there are many nanoparticles that you can, they are made out of iron. They can be in contact with wounds because the iron is biodegradable. And you can actually do wireless power transfer to heat them up. You will heat them up enough for the bacteria to suffocate without damaging the wound, and you will only feel it like warm. And also, if you have a hydrogel level underneath, you could actually decompose this hydrogel slowly or at a rate that might consider useful, so that these healing factors are actually constantly dropping to the wound and making the wound heal faster. So yes, I agree, this will be that is something that I hope we will see in the future, as it will mitigate or reduce significantly the amount of attention that the patient needs to receive from the nurses, and it will be providing them a personalized care, because depending on the geometry of the wound and how the patient is reacting in terms of how the wound is healing up, this system would be able to proactively take over and help the wound to recover faster. So very good idea.
Good.
Yeah, I appreciate the questions.
Thank you.
Thank you.
Let's go to Tom.
Very interesting to hear all that you had to offer for medicine in very poor countries. It's very hard to think that a lot of these ideas might die in the lab. And what I'm wondering is that, have you tried approaches rather than going to companies that might profit from these products? Is there any part of the World Health Organization that is open to hearing about these things? And other health organizations like Pan American Health Organization, and also people like Warren Buffett and Bill Gates and people of that sort. Have you tried?
Those are very good questions. Notice that as I acknowledged before, the system is a little rigged towards generating profits as much as possible, and that's why, for example, like Purdue is a great university, but the way the patent office works is like they put you in contact to people as they expect that they will buy the patents and make a revenue out of it. So all these non-profit organizations that might have the capability of manufacturing this or take this technology to places where they are clearly not going to pay for it, they just happen not to be up in the priority list, and that's why I don't get to contact those as much as possible. I do acknowledge that my students, or the best way for me to recruit the students, is to show them how their technology actually makes a change. And there are some collaborations that the industrial engineering department at Purdue here has with non-profit organizations and with the Red Cross and other organizations, but they are more into the logistics of how to move things from one side to another. And basically, every time I was into like telling them, hey, I have these edible sensors that will be able to actually check if the logistics are fine, and then like if things are delivered on time, or and if the food is just arriving the way you think it's arriving. And it's just it becomes complicated because they don't have the capability to produce these systems, and I can donate up to, like, I can donate small numbers, meaning like my lab can easily make 500, but it is not basically it's not the job of my lab to kind of like provide them with all the ones that they need, and it definitely feels sad. So I definitely could probably put like I'll put more weight on the fact that I maybe can do more to be proactive myself and not have to just to approach like these companies just in case they might happen to have a donation or something that allows us to produce a larger number and of samples. So I appreciate the comment a lot. Yeah, thank you.
Thanks, Tom. Marv?
It's somewhat in the same vein. This is as much a comment as it is a question, and it's to do commercialization. I spent most of my career working with startups, and many times, for quite a few years, I worked for venture firms, doing due diligence or being a hitman, going in and repairing things, being on the board. And there was one commonality. A lot of times it was research coming out of Brown or someplace like that, MIT, that was looking to be commercialized. And there are some commonalities that I learned over the years. And I would go into virtually every first session after a number of years of learning this and put on the whiteboard a statement. And the statement was, you can sell anything that's new as long as 90% of it's old. And that, the problems that I always saw was that, and it was necessary, whether it was researchers or entrepreneurs, they had the arrogance of vision. They knew what they were trying to accomplish. They knew the right way to do it. That was absolutely critical for them to get to that point. I mean, if you didn't have that, you didn't have anything. But there's a transition point. And the transition point is, especially with new technologies. I mean, if you say 90% old, 10% new, that makes a lot of sense if you're going from Windows 11 to Windows 12. You don't want somebody to learn something brand new from scratch. You want to introduce something that's similar to what they know. When you're introducing a completely new product to the world, you're not replacing something, or if you are, you're replacing something that you know you're replacing, but the customer is adapted to that and doesn't want it to be replaced. And there's a lot of research on that. So my comment and question is, what I found to be the most effective way to accomplish that is to put yourself in the role of the client and find out what is that 10% that's new, that's addressing something that's 90% old. And what I mean by 90% old, clearly when you're introducing the first spreadsheet in the world, to most people, it's not 90% old. What you're looking for is, in my case, when we sold the first VisiCalc, it was to Millipore Corporation in 1979 to a strategic planner. He hadn't been using computers. They'd been using, broadsheets, and to him, the problem was 90% old. How does he run scenarios? So instead of saying, hey, we got this great technology that does this, that, and the other thing, we'd say, we can automate your scenarios. And so he's automatically at 90% old. And I think that's, especially since the economics are going to have to work out here, finding somebody who's already has a pain point, and that's not easy. Some budgetary stuff, I wouldn't even suggest this right now, but I'll just say it. I found the most successful scenarios was where somebody was dedicated to doing that, who understood the world.
Yeah.
Yeah, because otherwise, you know, you hit the first speed bump and you take it as a no. And entrepreneurs are not used to dealing with somebody who says no. And researchers are less so. And so it's a comment of, you know, or suggestion, but I'd like to get your feedback. And does that fit your experience?
Oh, it does fit my experience like significantly. And one of the things that was getting me particularly frustrated about this is like I sometimes approach companies with NSF has something that is called SBIR programs. So these programs are basically to transfer technology from the university or the academy into companies. And I come with this and I'm saying, okay, guys, I'm giving you the shopping list with all the materials that you need, how to process it. I'm going to be like, teaching you how to make it. You have the equipment, the materials are not expensive. And again, I'm happy to do this and I will give you samples and I will actually test what you do just to make sure that it performs as nicely as the parts that we make, and we are going to be covered by this initial funding, but this they still perceive that there is going to be a lack of sustainability, and very recently, or particularly with companies that are a little bigger, particularly I would say like Apple, Meta, they rather buy you all. Like they are very concerned about losing their IP. So they rather put like they rather have like you make your company and then like they will take you. It's a way more financially sound approach than and again like basically what they told me is like the salary of our engineers is gonna be eating in about a week all the money that like this SBIR is giving you. So that's why this sustainability issue is important. But one thing that I can take from at least from the last two comments, like Tom also mentioned this, is like there are always approaches, and you just have to not stop, like not being discouraged, and to keep on searching, and that's actually the way you make an impact through invention and through convincing people about like adopting your technology and giving it a try, and then they can decide. So, Eddie, you got a question?
Yeah, Eddie, you get the last question.
Okay, I'll just be brief. I've been on both sides of the patent issue in university and also in business. And often I find universities expect far too much return on a patent, which causes a lot of businesses to just say, I'm going away. Another thing is that, to Marv's point, what you really need is to find someone who really knows the business that they can use your stuff in, or someone who can create a business. SBIRs I find iffy in many ways, because you really have to get from the SBIR straight into some kind of marketing process after the SBIR. Otherwise, you're probably going to flake out. I always find it just depends on characters, on specific people who can carry your idea to a very specific use case that, as Marv pointed out. And I think that's unfortunately where you need.
Yeah,
I think one needs to go.
You actually mentioned this idea that the basically priority, that's what I've seen. Like priority is given to all those contracts that are over 200K. And there are some companies that, like, at the beginning, I understand that they might not trust this research, or they might have issues and they don't want to go that deep. So if there was a mechanism that will allow us to kind of like, or allow me to have a couple of summer students making samples, so this company would actually be able to see how they work with whatever is the system that, or the testing system that they have on their facilities. That will be making it easier to kind of like, you know, it's not like with these innovations, it's better to send a teaser than waiting for the whole movie, because I mean, like, you might not have money for the whole movie, or like, and just working with a lot of constraints might not make the movie as good as it could be. So
I'd suggest hooking up some of your students to some really good marketing guy. Maybe they'll make a company that will use what you got.
Yes. Ramses, we should let you get back to your university activities now. We've kept you a long time today, and I appreciate it. You know, it occurs
it's been a pleasure.
the remarkable changes that have occurred over the last couple of decades at the interface between engineering and healthcare have just been remarkable. But you've added a new dimension to that. And I want to thank you for this presentation. You've given us a vision of where the healthcare may be in the next decade and where it's moving. And I think from our point of view, and hopefully to the point of view of people who watch this video when it's broadcast, I think you've made a really important contribution. So I thank you for that. I will see you next week when I'm on campus. And in interim, I will just say boiler up. How's that?
Thank you for your attention. It has been a pleasure
Okay.
participating in this forum.
All right, everyone.
Thank you.
Yeah, thanks, everybody. We'll be back in 2 weeks, and we're going to talk in 2 weeks with Bill Hilliard about renewables. So another topic of interest to this crew. Take care, everybody. Have a good weekend. Thanks, Ramses.
Bye, guys.
Bye-bye.